This video is on sequences of transformations. So first, let's recall that reflections flip. So if you have triangle ABC and you reflect it, A is going to flip over here. That would be A prime. C prime would be here, and B prime would be there. So you notice A and C have flipped. Rotations turn an object. Translations are a slide, right, left, up, or down. And dilations make an object smaller or bigger. Please remember you can pause this video at any time to write down your notes or to take a minute to think about it. All right, so number one, which sequence of transformations will map triangle ABC into triangle A prime, B prime, C prime? Well, the first thing I notice about this graph is that the triangles are different sizes. So one thing that had to occur was a dilation. So I'm going to mark out answer choice A and B because they don't have the word dilation in there. All right, answer choice C says a translation. Remember that slides it right, left, up, or down. And this triangle, there's no way. All right, so let's go to A to A prime. To go from A to A prime, you would go left 1, 2, 3, 4, 5, 6, 7, 8. You would go 8 left and up 1. Well, if you notice, to go from B to B prime, that's not the same thing. You don't go left and up to get to B prime. So that was not a translation. So this triangle has been rotated, If we go from A to the origin to A prime, looks like it makes a right angle. Number two, describe a series of transformations that can be used to prove triangle ABC is congruent to triangle DEF as shown in the right. If we can say that there was a reflection, rotation, or translation, or some combination of those, we know they have to be congruent because reflections, rotations, and translations all preserve the size. So if we want to prove they're congruent, we're not going to use a dilation. And if you look, it doesn't look like it got any bigger or smaller. So we're going to be using reflections, rotations, translations. All right, well, you got to pay attention to what order they gave you. A came first and then D came first. So A needs to go to point D. So here is A. It needs to match with D. B needs to match with E. B needs to match with E. And C needs to match with F. C needs to match with F. If C needs to go to F, that means I need to flip this. And there's a couple different right answers for this one, but I'm going to reflect it over the x-axis. So let me count. B is 1, 2, 3 above, so it goes 3 below. A is 3 above, so it goes 3 below. And C is 1, 2, 3, 4, 5, 6. So it goes 1, 2, 3, 4, 5, 6. All right, so reflect over the x-axis. Reflect over the x-axis. And then I need to move it. So that's a translate. So I need to translate. I need this point to go. This was A prime. I need it to go to D. Remember, A needs to go to D. So I need to go 1, 2, 3, 4, 5, 6. Translate 6 to the right. All right, let's practice writing our rules. X, Y transforms to. All right, when you reflect over the x-axis, what happens? The Y changes. The Y changes. And when I translate 6 to the right, that means I need to add 6 to this first spot. So that would be the rule for this series of, for this sequence of transformations. All right, number 3, identify which sequence of transformations can map pentagon A, B, C, D, E into pentagon A double prime, B double prime, C double prime, D double prime, E double prime as shown on the right. So once again, I notice that C has flipped to the bottom. So C has flipped to the bottom. So when it flips, remember that's a reflection. So I'm going to mark out A because it doesn't have reflection in it. And after I reflect it, it would look like this. So this would be A prime, E prime, B prime, D prime, C prime. So the question is, do I need to follow that by a translation, or do I need to follow that by another reflection? Well, the correct answer is translation, because all I need to do is move it to the right. If I did another reflection, it would flip it. So A would flip over there, which is not what they have. A is staying on the left. So A prime is here on the left, A double prime is on the left. So all I need to do is slide it. I don't need to flip it. All right, I hope that makes sense. Number 4, the graph on the right shows triangle ABC in its image A double prime, B double prime, C double prime. Describe a sequence of rigid transformations which would map triangle ABC onto triangle A double prime, D double prime, C double prime. All right, so once again I notice that B is here and B double prime is here. So B is on the right here, but it's on the left here, so it has flipped. So I'm going to do a reflection over the Y. So a reflection over the Y axis first. So C is 2 points to the right, so it's going to go 2 points to the left. A, 1, 2, 3, 4, 1, 2, 3, 4. And B, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and so that puts me there. So it looks like the only thing I need to do now is go straight down. So that would be a translation. 2 units down. Let's practice writing our rule. X, Y goes to. All right, so let's do this first one. Reflection over the Y-axis, that changes the X. And then translation 2 units down, you subtract 2 in the second spot. All right, number 5. Which sequence, or triangle ABC and triangle DEF are mapped on the set of axes? Which sequence of transformations maps triangle ABC onto triangle DEF? All right, so again, A matches with D because those come first. They have them lined up. So A goes with D. E is in the middle right here. E is in the middle, so it goes with B. And that would mean F and C would match. Okay, let's just use our answer choices to help us. A says a reflection over the x-axis. So remember, this is my original. This is my original, and this is my second one. So if I reflect this over the x-axis, that would put A here. And then if I reflect it over the y, A and D do match up. But let's try another point. All right, if I reflect C over the x-axis, remember this is the x, so C is 1, 2, 3, 4, 5, 6 down, so it'd go 1, 2, 3, 4, 5, 6, it'd go there. And then when I reflect it over the y, it goes right there. So that one works. C goes to F. And let's try B. If I reflect B over the x-axis, and then B over the y would match with E. So it looks like A is my correct answer. All right, number 2. In the diagram, congruent figures 1, 2, 3 are drawn. Which sequence of transformations maps figure 1 onto figure 2, and then figure 2 onto figure 3? All right, so from 1 to 2, all the letters are in the same order. So that was not a reflection. They didn't flip. They stayed in the same order. So that's not a reflection or a rotation. All this did was slide to the right and up. Now, if I go from 2 to 3, A has turned to there. Sorry, A prime has turned to A double prime. B has turned. This whole figure has been turned. And if I draw from D prime to D double prime through the origin, makes a 90-degree angle. So this has been rotated 90 degrees clockwise. So that is a rotation, D. Number 7, a sequence of transformations maps rectangle ABCD into rectangle A double prime, B double prime, C double prime, D double prime as shown in the diagram on the right. Which sequence of transformations maps ABCD into A prime, B prime, C prime, D prime, and then maps A prime, B prime, C prime, D prime onto A double prime, B double prime, C double prime, D double prime? All right, so this is our first one. It has no primes. This is our second one. It has 1 prime. And this is our third one. It has 2 primes. So I noticed from 1 to 2, A was in the top left, and now A is in the bottom left. So it has flipped. So that is going to be a reflection that happened first. And then I noticed that this one has been turned. It was going horizontal, and now it is vertical. So it has changed orientation. So that would be a rotation. It has turned. It now goes up and down. Let me go back to number 5 real quick and show you one other strategy you can use. A is at -2, -2. That's not a good point to choose because they're both 2's. Let's try C. C is at -1, 1, 2, 3, 4, 5, 6, -6. And remember, C matches with F, so let's look at F. F is at 1, 6. So a reflection over the x-axis changes the y, and a reflection over the y-axis changes the x. So if you notice from C to F, the x has changed signs and the y has changed signs. So that's another way to look at it, is to pick a point. If you look at B at an 180-degree rotation about the origin, that does change both their signs, but then a reflection over the line y equals x would make them change positions. That's the rule for that. And you can get out your green sheet today and look at that. That would be a good tool to have. So it changes positions. And if you look again at the point we chose from C to F, they did not change positions. So another way to do these is use your rules. All right, 2 more. Number 8 down on the bottom. All right, name at least one sequence of transformations that will carry each pre-image into its image. Use the correct transformation notation. All right, I noticed that from this one to this one, it got bigger. So the first thing that has to happen is a dilation. All right, got bigger. And if there is a dilation, I would do that first. That's the easiest thing to do first. So from D to C, the bottom part of this trapezoid, from D to C, is 2 units long. From D to C is 2 units. Let's look from D prime to C prime. So from D to C was 2. All right, from D prime to C prime is 1, 2, 3, 4, 5, 6. So to go from 2 to 6, you have to multiply by 3. So a dilation by a scale factor of 3. Okay. All right, and let's do that at the origin. Okay. All right, so C is right here, which is -3, -3, -3. And if I multiply that by 3, that would put me at -9, -9. So C was at -3, -3. This one's kind of tricky If you need to, you can replay it. This is probably one of the hardest ones. So C was at -3, -3. If I dilate it by a scale factor of 3 to make it the right size, it puts me at -9, -9, which is way off of what it needs to be. It needs to be at 1, 2, 3, -3. So I know it needs to end up at 3, -3. So what I'm going to do is ask myself, how do you go from -9 to +3? You have to add 12. So I need to translate it, x plus 12, and then I'm going to ask myself, how do I go from -9 to -3? I need to add 6. To go from -9 to -3, you would actually add 6. So that would be my second thing I would need to do to make. So the first thing I did was blow that up, and then I have to move it to the correct position that I want it to end up at. All right, last one, number 9. All right, I noticed that H and T were on the left, and now they're on the right, so I need to do some sort of reflection. I'm going to reflect it over the X. There's a couple different ways to get the right answer, or there are a couple different right answers, but I'm going to do reflection over the X axis. So A was 1, 2, 3 above, so it goes 3 below. T was 3 above, so it goes 3 below. H is 5 above, so it goes 5 below. Okay, so that's where it ends up. And wait, that did not work, did it? Sorry, that was a mistake. Okay, sorry. Let's reflect over the y-axis. So sometimes you have to guess and check on these. So let's reflect over the y. So 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So it'd go 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 1, 2, 3. All right, now that's in the right. Now that looks in the right direction, okay? So now I need to make A go to right here. So I need to move it left 4. So that's a translation. So I need to go left 4, so that would subtract 4. 1, 2, 3, 4. And I need to go down 1, 2, 3, 4, 5, 6. I need to go down 6. And that works for all of them. If you take H, go left 4, down 6. Get you in the right spot. T, left 4, down 6. Okay?